Hello dear students, how are you? I am Vivek Sharma, your mathematics teacher. In this video lecture, we will discuss about the exercise 3.3, which is based on the algebraic methods of solving a pair of linear equations in two variables. Please like, share and subscribe my YouTube channel. So as we know, there are three algebraic methods for solving pair of linear equations in two variables, which is method of substitution, method of elimination and method of cross multiplication. As already we have discussed the method of substitution in last video lecture, so here we will discuss exercise 3.3, which is totally based on method of substitution for solving a pair of linear equations in two variables. So let us do question number first of exercise 3.3. Solve the following pair of linear equations by the substitution method. Here I am solving only those parts which are important. Okay, so let us take third part. The given system of equation is 3x minus y equals to 3 and 9x minus 3y equals to 9. We consider 3x minus y equals to 3 as equation number first and 9x minus 3y equals to 9 as equation number second. We have to apply substitution method and try to find the values of x and y. So I am taking equation number first. So from equation number first, we get the value of y equals to 3x minus 3. Now substituting this value of y equals to 3x minus 3 in equation number second. So after putting this value, we get 9x minus 3 multiply bracket 3x minus 3 bracket close equals to 9. It implies 9x minus 9x plus 9 equals to 9. We get this equation by solving. After solving this, we get 9 equals to 9. When such type of condition arises in the question, we say this statement is true for all values of x. Why we say? Because if we don't get a specific values of y or x as a solution, so we cannot obtain a specific value for x or y. So in this situation here, we don't get a specific value of x as a solution, so we cannot obtain a specific value of y. So this situation has arisen because both the given equation are the same. So it means when the equations are the same, so in that case we say that equation number first and equation number second have infinitely many solution. We say equation number first and second have infinitely many solution. Let us do fourth part of question number first. The given system of equation is 0.2x plus 0.3y equals to 1.3 and 0.4x plus 0.5y equals to 2.3. I consider 0.2x plus 0.3y equals to 1.3 as the equation number first. When I multiply this whole equation by 10 in LHS and RHS, so I get 2x plus 3y equals to 13, and I consider this equation as the equation number second. Now I consider 0.4x plus 0.5y equals to 2.3 as equation number 3, and I multiply this whole equation by 10 in LHS and RHS, so I get 4x plus 5y equals to 23, and I consider this equation as a equation number 4. Now we have to solve this pair of linear equations in two variables by substitution method. So I take equation number 4. So I can write equation number 4, 4x plus 5y equals to 23 as 5y equals to 23 minus 4x. On solving, we get the value of y equals to 23 minus 4x by 5, and I consider this is as a equation number 5. Now I substituting this value of y equals to 23 minus 4x by 5 in equation number 2 in place of value of y. So we get 2x plus 3 multiply bracket 23 minus 4x upon 5 bracket close equals to 13. Now on taking LCM, we get 10x plus 3 multiply bracket 23 minus 4x upon 5 equals to 13. On solving, we get 10x plus 3 multiplied bracket 23 minus 4x bracket close equals to 13 multiply 5. On solving, we get 10x plus 69 minus 12x equals to 65. So on solving again, we get minus 2x equals to 65 minus 69. So again on solving, we get minus 2x equals to minus 4, and finally we get x equals to 2. So after solving this equation, we get the value of x equals to 2. Now putting this value of x equal to 2 in equation number 5. So the equation number 5 is y equals to 23 minus 4x by 5. So we put the value of x equal to 2 in equation number 5 in place of x. So we get y equals to 23 minus 4 multiplied 2 by 5. On solving, we get y equals to 15 upon 5. On solving, we get y equals to 3. So after solving it, by get y equals to 3. So hence the solution of the given system of equation is x equals to 2 and y equals to 3. So let us do fifth part of question number first. The given pair of linear equations in two variables is root 2x plus root 3y equals to 0 and root 3x minus root 8y equals to 0. I consider root 2x plus root 3y equals to 0 as equation number first and root 3x minus root 8y equals to 0 as equation number second. Now I take equation number first. The equation number first is root 2x plus root 3y equals to 0, and on solving I get the value of x, which is equal to minus root 3y upon root 2, and I consider this it as a equation number third. Now after getting the value of x, I put this value in the equation number second, and the equation number second becomes root 3 multiply bracket minus root 3y upon root 2 bracket close minus root 8y equals to 0. On solving, I get minus 3y upon root 2 minus root 8y equals to 0. On solving, I get minus 3y minus 4y upon root 2 equals to 0. On solving, I get minus 7y equals to 0. On solving, I get y equals to 0 upon minus 7. And finally, I get the value of y equals to 0. Now, after getting the value of y, I put this value of y in the equation number third. So the equation number third is x equals to minus root 3y upon root 2. So on putting the value of y equals to 0 in equation number third, so we get the value of x equals to 0. Finally, the solution is x equals to 0 and y equals to 0. So let us do question number 2 of exercise 3.3. Solve 2x plus 3y equals to 11 and 2x minus 4y equals to minus 24, and hence find the value of m, for which the given equation is y equals to mx plus 3. So the given system of equation is 2x plus 3y equals to 11 as a equation number first, and we consider 2x minus 4y equals to minus 24 as a equation number second. First of all, we take equation number first. The equation number first is 2x plus 3y equals to 11, and on solving we can write it as 3y equals to 11 minus 2x. On solving we get y equals to 11 minus 2x upon 3. We get the value of y here, and we consider it as a equation number third. Now substituting this value of y in equation number second, and equation number second becomes 2x minus 4 multiply bracket 11 minus 2x upon 3 bracket close equals to minus 24. On solving we get 6x minus 44 plus 8x equals to minus 72. We get this value after taking LCM and cross multiplication. So on solving this equation, we get 14x equals to minus 72 plus 44. On solving, we get 14x equals to minus 28. On solving, we get x equals to minus 28 upon 14, and on finally solving, we get x equals to minus 2. Now after solving this and after getting the value of x, we put this value of x in the equation number third, which is y equals to 11 minus 2x upon 3. Now on putting the value of x, the equation number third becomes y equals to 11 minus 2 multiply bracket minus 2 bracket close upon 3, and we get y equals to 11 plus 4 upon 3, and finally we get y equals to 15 upon 3, and finally we get y equals to 5. Now after getting the value of x equals to minus 2 and y equals to 5, we put this value of x equals to minus 2 and y equals to 5 in the equation y equals to mx plus 3. So we get 5 equals to m multiply bracket minus 2 bracket close plus 3. So it implies we get minus 2m equals to 5 minus 3. It implies we get minus 2m equals to 2, and finally we get m equals to minus 1. This is the value of m which we want in the given equation. Finally, here we have understood from question number first and question number 2 how to solve the substitution method. Please do some extra questions at your home, and here I have uploaded some questions PDF in the description box.